At this point in the course, we already learned a lot about React, though I will say there also is more left to be learned. But everything we learned up to this point was about React doing things inside of our app in the browser. And of course, that is why we do use React. That is its main job. But we also only worked with local data up to this point. So we only played around with dummy data, which was always just managed and stored in the browser. In this course section, we are going to dive into how you may connect your React application to a backend, to a database. Because, of course, many applications, probably all applications, need to fetch data from a database or store some data in a database eventually. No matter if we're talking about users that need to be created and stored and logged in, or if we're talking about products that need to be loaded, or anything like that. And therefore, this section is about establishing such a connection, and it is about sending HTTP requests from inside our React app to a backend. And specifically, we are going to learn how exactly React apps do interact with databases, because whilst it's simple, as you will learn, it will not necessarily work as you expect it to work. You will learn how you can send HTTP requests and work with responses which you get back. And we're going to have a look at how we can handle errors and loading states in our application. Now, before we dive into any demo or any code, let's understand how React apps do talk to databases. And as you can tell by the title of this slide, it's not working as you maybe thought it works. Because React apps, or in general, browser-side apps, browser-side code, so JavaScript code running in the browsers, should never directly talk to a database. So if you have a React app, and then some kind of database, SQL database, a NoSQL database like MongoDB, it does not matter. If you have such a database running on some database server, then of course you might want to fetch and store some data and you might want to establish a connection, but that's not what you should do and that's not what you'll ever see out there in the wild unless it's a highly insecure and bad written application. Because if you would directly connect to a database, if we leave aside that this will technically be challenging, but if you would do that, if you would directly connect to a database server from inside your client side, your browser side JavaScript code, you would expose your database credentials in that code. Because you must never forget that all JavaScript code running in the browser can be accessed and read not just by the browser, but also by the users of your website. Simply open up the developer tools and you can view all the code there. This generally is no problem, and attached you find a more detailed article and video which I created on this. But of course it will become a problem if you expose security relevant details in your code. For example, credentials that allow access to a database. In addition, directly connecting to a database could also bring other problems like performance issues, but the security problem is the biggest problem of all. So therefore, instead of directly talking to a database from inside your React app code, you always take another route. You have a backend application running on another machine, not running in the browser, but running on some server out there. Maybe on the same server as the database, often on a different server though. Now, this backend application can be written with any server-side language of your choice. Node.js, PHP, ASP.NET, everything is possible. And it's this backend application which will do the talking to the database. Because you can safely store and use database credentials on the backend application, since that backend code can't be viewed by your users. It's on a different server and the users of your website will never see that code. And therefore, the React app will then talk to that backend server, to that backend API typically, which is a server which exposes different URLs requests can be sent to, and we're going to see this throughout this section. And then you have a safe connection to the database because the credentials are on this backend app. And for talking to the backend app, no security relevant details are needed. This is how this works, and this is what we're going to see in action in this course module. Now, I prepared another dummy application for you. Of course, you find it attached. It has two dummy movies, which are being rendered here, and this button, which currently doesn't do anything. Now, the code for this is fairly straightforward. It's an app component, which renders a section with this button, and which then renders a movies list component. And currently, I just have some dummy movie data, which is fed into the movies list. And in the movies list, I simply loop through these movies to output the individual movie components, which render list items with, well, this content. And that brings this here to the screen. Now, at this point in this application, as I said, we're just using some dummy data here. I want to change this now. I want to fetch data from a database which contains some example movies. And for that, I'll use the Star Wars API. You can visit swappy.dev for Star Wars API. And here you have a little dummy API with some dummy data which you can send requests to play around with it, basically. Now, I will say right away, this is an API. It's a backend app. It's not a database because of what I explained in the last section. Behind the scenes, it of course probably uses some database to store some data about the Star Wars movies, but we interact with this backend app. And I said API a couple of times. API stands for Application Programming Interface, and it's a very broad term, not just related to React and HTTP requests. In the end, it means that in our code, we're dealing with something which has a clearly defined interface, clearly defined rules on how we can achieve certain results and do certain tasks. And when we talk about APIs in the context of HTTP requests, we typically talk about REST or GraphQL APIs, which are basically two different standards for how a server should expose its data. Now, this is a REST API, and it simply means that there are a couple of URLs, like this URL, which you see here, to which you send a request to get back data in a certain format. And different URLs to which you send different requests will give you different chunks of data. That's what makes it an API. You got different entry points which lead to different results. If you want to learn more about REST APIs and what exactly that all is, you'll also find a helpful resource on that attached to this lecture. So here we can basically send a request to this URL, for example, to get information about a certain person from the Star Wars movies. We can also grab this URL here and send a request to swappy.dev/API/films, and we will later get back a response with a bunch of objects describing the different films, the different Star Wars movies, with, for example, the opening crawl text and the title, the episode ID, and so on. Now, this is just a dummy API, which I want to use for getting started with sending HTTP requests. That's why I'm having a look at this first. And this is the API to which we now want to send requests from inside our React application here to populate this list of movies here with some real data instead of our dummy data. And how does this now work in React? Now, when it comes to sending requests from inside React apps, we must not forget that in the end, we're still writing regular JavaScript code, right? A React application in the end is just a JavaScript application. That is what it's all about. And since that is the case, we can of course use any send HTTP requests in JavaScript solution which we want. For example, there is a package called Axios, which you could use. You can visit it on GitHub, which makes sending HTTP requests and dealing with responses very, very simple, no matter which JavaScript library you might be using. You can even use it without any library. But nowadays, we also have a built-in mechanism for sending HTTP requests from inside JavaScript, and that's the Fetch API. The Fetch API is built into browsers, and it allows us to fetch data and actually also to send data, even though the name doesn't imply it. And we can use that to send HTTP requests and work with responses. And therefore, it's the Fetch API, which I want to use here to get my movies. Now, we can start simple and make sure that whenever this button here is clicked, we do fetch movies, and then we display the movies. And for that, I will simply remove my dummy movies here, and instead add a new function here, which I'll name fetch movies or fetch movie handler. Fetch movies handler is probably a better name, like this. And in here, we can now use fetch, this function, because that's a function the browser makes available to us. That's this Fetch API being used. And in its simplest form, we just need to pass in as a string the URL to which you want to send a request. So in my case, swappy.dev/API/films. To be precise, HTTPS and then that URL. We could provide a second argument here, which allows us to pass in a JavaScript object where we configure various options, for example, where we add extra headers or an extra body or change the HTTP request method. But here we don't need that because the default method will be get. So by default, a get request will be sent. And that's all we need here for the moment. So that will now send such a HTTP request whenever this function is called. But of course, we also want to handle the response. And fetch returns a promise, which allows us to then react to the response or any potential errors we might be getting. Now we're getting a promise here, which is an object which will eventually yield some data instead of immediately doing that, because of course, sending a HTTP request is an asynchronous task. It doesn't finish immediately. It can take a couple of seconds or milliseconds. It can even fail, of course. And therefore, we can't just continue in the next line of code and use the result immediately. Instead, the result will be there at some point in the future. And that's exactly what promises exist for in JavaScript. So we can add then here to define a function which will be called whenever we got a response. And we could add catch to handle any potential errors. But for the moment, let's ignore that and let's focus on the then case. Here we get a response, and then here I'll write an arrow function. We get a response, and then in this function body, we can use the response. And this response argument here is now actually an object with a bunch of data about the response. For example, we can read the response headers, we can get the status code. There also is a utility OK field, which will be true if everything worked, and false if we got some error. But here we're now interested in the response body. And this API sends back data in JSON format. JSON is simply a data format, a very popular one for exchanging data. And it looks like this. It looks like a JavaScript object, but keys are wrapped between double quotes, for example. And there are a couple of other rules you have to keep in mind as well. Also, there are no methods, it's just data. And the advantage of JSON data is that it's very easy to translate it to JavaScript objects, but there is a translation step which needs to be transformed. Thankfully, the response object which we get has a built-in method which will automatically translate this JSON response body to a real JavaScript object which we can use in our code. All we gotta do for that is call JSON, which is a built-in method on that response object. And this will now do this transformation. Now this itself then again returns a promise. And therefore what we should do here is return that promise and then add another then block here, which will then be fired once this data transformation is done. And here we therefore then get our transformed data, which in the case of this URL will have this structure here. So it's an object with a count field, a next field, previous, and a results field, which then in turn holds an array. And it's this array I'm interested in here. So we can access data.results to get access to this array, like this, and then store these results in some state, which we then update in this place here, and which we then use here for movies list. So let's add use state and initialize an extra piece of state here in this app component. Let's say initially it's an empty array, and we name it movies and set movies. That's our state updating function. And here, once we got our movies, once we got the parsed and extracted movies, I will call set movies and set my data results. So this array here as my new state, as my new movies state. And now we just gotta forward movies here as a value for the movies prop. Now, one thing to note here is that in my application here, I'm actually extracting title, release date, and opening text from the data I receive. Now, there will be a title key, but opening text is actually called opening_crawl here, and release date is called release_date here. So we either adjust the prop names here, which I expect, or we make sure that we transform the incoming data from this format here to the format we expect in our app. And I'll do the latter. So in app.js, where we are making that HTTP request, before setting the data, the results as a new state, I'll actually transform them. So here I'll have my transformed movies, let's say. And that in the end will be data.results, which is this array we're getting back, .map to convert every object in the results array into a new object. And it's then the new objects, the array full of new objects, which will be stored in transformed movies. Now the logic for mapping here simply is that I get my movie data, or whatever you want to call it, which will have this format here, so like this object here, and I'm only interested in the ID, the title, the opening crawl, and the release date. So I will return a new object here, and this will be my movie object in the front-end application, which has an ID, which I get by accessing movie data.episode_ID. Because there is this episode ID field in the data we get back. And I now translate this into just an ID field in the data I'm working with here in my front end. Now for the title, we access movie data.title like this. And for my opening text, which I expect to get, I simply access movie data.opening_crawl. So the text stored in this opening crawl field will be stored in an opening text field here in the object I'm creating here. And then we also need the release date, of course, and that will be movie data.release_date. Now this is transformed, and now it's the transformed movies which I'll store here with set movies. Now to make sure that everything works, we now have to connect fetch movies handler, this function, to this button. And therefore, of course, here we add on click and point at fetch movies handler. If we now saved it all, we can go back to the React application. And initially we got no movies because I removed the dummy data. But if I click fetch movies, you see it takes a short while, but then this movie data shows up. And this is now fetched from this Star Wars API, and therefore from a backend app, which in turn is talking to a database. And that in a nutshell is how you do connect to a database from inside React apps. And since this is the wrong term, it would be better to say that this is how you send HTTP requests from inside React apps to a backend.